Across billions of light years, light is moving. Not in a way you'll ever see. The objects emitting it are too faint, too distant, too redshifted even for most telescopes. But one instrument has been systematically recording them thousands at a time. This is DESIsonica, and what you're about to hear is that data turned into sound. DESI stands for the Dark Energy Spectroscopic Instrument, a device mounted on the Mayall telescope at the Kitt Peak Observatory in Arizona. It splits incoming light into spectra, measuring how far each galaxy, quasar, or star has shifted towards the red end of the spectrum as the universe expands. That shift, the redshift, is a direct proxy for distance and cosmic time. DESI Data Release 1 contains reliable redshift measurements for tens of millions of objects across a redshift range of 0 to 4. 0 is essentially our neighborhood. 4 is the early universe, seen as it was nearly 12 billion years ago. Each object in that catalogue has a spectrum, a fingerprint of light. And DESIsonica's premise is simple. What does that fingerprint sound like? Before any audio plays, an offline pipeline is executed. It queries the DESI catalog, selects high-quality targets across equal slices of redshift, and fetches the raw spectrum for each one from a service called Sparkle. Around 7,800 wavelength measurements per object, spanning from near ultraviolet to near infrared. That spectrum gets compressed into a 128 number fingerprint, an I-128 imprint, capturing the essential shape of the light, its peaks, its absorption troughs, its overall contour. This is the thing that becomes sound. Let's look at the DESIsonica interface. The application starts with three main panels: the sky footprint, the bin histogram, and the spectra panel. More of that later. The bin histogram shows collections of objects according to their distance or redshift value. Items on the left are closer and items on the right are further away. Each bar in the histogram shows you the collection of objects that have been observed at that redshift. And we can see that each bin is made up of quasars, galaxies, and stars. The sky footprint panel shows you the position of the observed objects according to their right ascension and their declination. We can zoom in to get a better view, and we can hover our mouse over any object to get some brief details about it. We even show voids. Let's click out to minimize the panel. And now onto the bin histogram. The bin histogram is our trigger point for playing sounds. Clicking on the bin will play the sound. The spectra panel is populated. It's worth noting that during the pipeline process, the software chose the top 12 items according to attributes such as signal-to-noise ratio and confidence, and it's those 12 objects that we are seeing overlaid in the spectra panel. That is, the spectra from each object is overlaid on top of the other objects, producing a compound spectra. DESIsonica is effectively a spectral synthesizer. It takes samples from each spectral waveform and turns those into small oscillators, which are repeatedly played to produce a sound. The default view is to play each spectra sound concurrently, thus producing a chord. The sound isn't static. Each imprint also carries a brightness curve, 32 control points describing how the tone's character should evolve. The engine sweeps through that curve over a few seconds, opening and closing a low-pass filter, making the chord gradually brighter or darker. You can watch it happen. The gold line moving across the spectrum panel is tracking that sweep in real time. Below the spectral panel is a list of the active targets, those 12 key objects that were selected during the pipeline process. Clicking on any of those objects effectively solos it. And now we're just hearing the spectral analysis of that single object. And we can do the same for the other objects in that bin. Holding down the Command key or Control key allows us to multiply select different objects, thus building the chord up gradually. The pitch you are hearing isn't random. The root note is inferred from the bin's mean redshift, and the voices are spread across a musical scale chosen from the composition of that bin. So, bins dominated by stars lean towards pentatonic. Quasar-rich bins resolve to Lydian. Bins dominated by galaxies take on the Dorian scale. The astronomy itself suggests the harmony. To add a little color to the sound, DESIsonica has a built-in reverb engine that uses convolution reverb impulse responses. This slightly softens the sound. If we maximize the sky footprint panel, we also have a 3D view. This view is perfect for getting a sense of where the objects exist in a 3D space, including their distance from Earth, which is marked as the blue dot in the center of the globe. Objects that are currently playing in the selected bin are highlighted with a circle. We can switch off the auto-rotate and you can move the globe around at your pleasure. We can also look at the underlying raw data that was ingested during the pipeline process. We can see the 12 selected targets, and we can view the spectra for each target. We can solo them accordingly. There's a comprehensive help panel, which you can switch between a technical mode and a simple mode. So that's DESIsonica.